Good evening, and welcome to Star Classification with your host, Mr. Hernandez. Alright, so, don't be annoyed. Let's get right into it. Stars are classified by temperature. We talked about this briefly in the first section, where blue is the hottest, red is the coolest. Spectral types, these are O, B, A, F, G, K, M. There are several mnemonics that you can come with those letters. The old one is O, be a fine gal or guy, kiss me. That's the old one. I personally enjoy this one, which is only boring astronomers find gratitude knowing mnemonics. Cool. Alright, so Blue Star, here we have a picture of Rigel. It's class O. It's very hot and very young. It's very early in its lifespan. You can find that in the knee here of Orion. Then we get our white dwarf star, like Sirius. Why so serious? And that's a class A star. It's very hot, but also pretty darn old. These are one of the older stars that we're going to be able to find. It's actually getting dimmer and dimmer and dimmer and dimmer and dimmer until finally it won't be there anymore. But we'll talk about that when we talk about life cycles of a star. Alright, then we get our star. Aw, our sun. It's so cute. It's a class G. It's right in the middle. It's middle-aged. It's as average as it comes. But it's so cool. Alright, then we get Betelgeuse. Betelgeuse is a pretty wicked, awesome star. Betelgeuse here is in the armpit of Orion. It's a super red giant. This is our class M. It's older than a yellow star, so it's older than our star. This is what our star will become. Well, not a super red giant like Betelgeuse, but a red giant. And younger than a white dwarf star. So, something to note. Size-wise, Betelgeuse is huge. Take a look at it. This is Betelgeuse. That's us. Look at this. You see the little dot? That's us right there. That's us. This is Betelgeuse. Right here. Look at us. Right over here. Oh, we're so little. So, Betelgeuse, very, very big. Alright, electromagnetic spectrum. This is radiation from the star. This is the light given off from the star. Not just visible light, but all the light. And what it does is it splits it up and it organizes it by the elements, which kind of act like fingerprints inside of the star, and it lets us know what that star is made up of. So, the most common here are these absorption spectrum right here, and you're going to find these in stars, galaxies, nebulas. Other types of spectrum are continuous and emission. If you had chemistry or earth science, you probably saw an emission spectrum. This is what those little glass tubes that make that noise when you turn them on give off when you look through a spectroscope. But this absorption line is what you're going to want to look for. So this is our Roy G. Biv of the visible light, and these are the elements that are being absorbed by those stars, and let us know what's making it up. Alright, speaking of wavelengths, light sort of moves like a wave, and that means it has different wavelengths. So high energy, low energy, medium energy, and that's where we get our visible light here. So here we have it towards the red spectrum, so low energy, so low temperature, low wavelength. Our yellow stars, so it's right here in the middle, and then our blue stars, which have lots of energy and are very hot. Alright, so how bright is a star? So we talked about luminosity. Luminosity, again, is the total amount of energy emitted by a star, galaxy, or other astronomical object, and it's related to how bright it is. Now there's two types. There's what a star looks like here from Earth. That's the apparent magnitude, so that's what it appears to us. And then there's the actual magnitude, or the absolute magnitude, and that is how bright a star actually is, or should be, based on its size and temperature. So if we were to put all the stars right next to each other and compare them, that's what absolute magnitude is hoping to achieve. For example, if you take a look at our sun is the brightest thing in our sky. When it is daytime and it is not cloudy, we are not seeing any stars unless we have a solar eclipse. So, if we were to then take that absolute magnitude, this is what it'll look like. Not very bright. Alright, that concludes our lesson. I will see you next time. Same science channel, same science place. Be kind, rewind.